The MTDCNC Podcast, sponsored by Langley Alloys, unique metals for demanding applications, providing first-class performance and an international service.
Welcome to the MTDCNC Podcast. I'm joined today by Paul Buckley, and we're here at Colchester Machine Tools Solutions in Elland, in West Yorkshire, near the Pennines. It's really beautiful around here, isn't it?
Yeah, very nice.
Yeah, it's gorgeous. I came in on a train, and it was just, coming into Huddersfield, it's like you're up over the valley. Really, really gorgeous around here, and loads of really good engineering, lots of good engineering heritage, especially here at Colchester. It's kind of the heart of machine tools. And it has been for a long time. But before we go into what we're doing here today, I'd like to say thank you to Langley Alloys for sponsoring the MTDCNC podcast. Langley Alloys are specialists in super duplexes, Inconels, really high performance materials. They have their own branding. Ferralium 255 is one of their special materials that's very well known. One of their materials has even been used in the refurbishment of the Statue of Liberty. So there's some really interesting history there with Langley Alloys. So thank you very much for sponsoring the podcast. Okay, so here we are at Colchester Machine Tools Solutions. Welcome, Paul.
Thank you.
Yeah, thank you very much for coming, donating your time to us today. Really appreciate it. Let's start a bit of a background. Sorry, by the way, my name is Rowan Easter-Robinson, if you need a bit of background on me, from MTDCNC. And Paul, how did you start and you've had a lot of experience in the manufacturing industry. It's safe to say. You're not that old, but you've had a little bit of experience.
Been around for a long time.
Been around a little bit. What's your background? Where did you start in engineering?
I originally started off in plastics manufacturing. And as a consequence of that, I then got into coding and marking, traceability in effect, and that's pretty much been my entire career.
Yeah, and how important is coding and marking to plastic? Plastic injection molding is kind of like telling someone when a plastic part has been injection molded.
It was more initially, bizarrely, for pubs.
Oh, really?
It was actually marking the plastic pipes with the pump number or the beer type or whatever. So
you don't mix your stouts and your ales.
Exactly. So it could be connected to the barrel in the cellar and connected up to the right pump at the bar. And
I guess if you think about it, a pub is just like the back of an electrical cabinet in a machine tool, isn't
exactly.
it? You got to mark up every single wire, mark up every single pipe, or someone's going to think they're getting Guinness and they're getting a Pilsner.
Yeah, and in some cases you could have 30 separate things and 30 separate pipes.
In one of the good pubs, you'll get 30 separate things, won't you?
Absolutely.
Yeah, brilliant. That's fascinating. So you started there, and then kind of what led you up to being here talking to us today at Colchester Machine Tools?
Again, really, it's just been as I say, my career sort of followed traceability, coding and marking. So I started off with inkjet printers, and then sort of as the technology changed, I got into laser systems. Yeah.
So the move from laser inkjet to laser, what was that like?
Very different. Laser is a much more pleasant environment to work in, rather than working with inks and solvents and sort of working in food factories.
As soon as you touch printering, it doesn't come off, does it? Really?
Absolutely, yeah. I spent probably 20 years with continuous black fingernails.
Oh, I bet you did. I bet your other half wasn't so happy.
Not overly pleased.
No. You're trying to clean you up on a Sunday to go to a party or a family event, and you're there with fingernails covered in black ink.
Yeah, and it really is very difficult to get off.
Yeah. Okay. And then the transition to laser. When was that?
Transition to laser would probably be about 2005. Yeah. So 20 years ago, so I've been involved with lasers for 20 years or so.
And that technology was quite different than what it is today.
Yeah, it was. Very, very sort of basic technology. The very first laser that I worked on wasn't like the ones we've got now, where we've got the steered beam. It was just basically firing a laser through a metal stencil.
Yeah.
Down
so a big fat beam.
Yeah,
and
big fat
blocked
beam
by the stencil.
Exactly.
You put in front of it.
So it really was glorified stenciling.
Yeah. Wow, that's fascinating. And then nowadays, bringing us right up to speed now with brand new laser engraving. We're talking today. Kind of one of the reasons we're here at Colchester Machine Tool Solutions is because you've got a brand new machine that's been designed by Colchester and assembled right here.
Yeah, that's right. It's again, for us, it's all part of the traceability market, and it's a complementary product to a lot of the machinery that we use and sell. Obviously, these go into engineering shops, and all sorts of different products are manufactured. Anybody particularly that's manufacturing for aerospace, motorsport, those types of things, all the products that they manufacture either need some form of traceability, or in a lot of cases people will put their own logos, their own branding, serial numbers, just traceability onto metal.
Yeah.
And the best way to put the traceability onto metal is using a laser.
Absolutely. It's fascinating to see the history of Colchester Machine Tools here. Is you are still pushing, still making brand new products. I mean, there's a Colchester student lathe, I think, just down here in the corner. And,
yeah,
this is a new iteration.
Yeah.
But a version of that machine tool has been used almost for a century in this country and around the world.
Yeah, I think probably pretty much anybody that did metalwork at school and used a lathe learnt on a Colchester student, and they're still very, very popular in colleges and schools. It's the basic for an engineer to start.
Yeah, definitely. I mean, I might be a little bit biased here, but I think the longevity of the brand and the heritage is something a little bit to do with the fact that it's been brought up north a little bit.
I think so.
Yeah, we both might be a little bit biased there in that case. But yeah, so the history of Colchester is a fantastic one. But what I find fascinating is that heritage of good engineering, good experience in supporting manufacturing in not just the UK, but it's worldwide as well.
Yeah, Colchester brand is pretty much in every country. We have different Colchester distributors throughout the world: Australia, Germany, America. So it's a worldwide brand, a recognised brand, and a trusted brand.
Yeah, absolutely. And this laser's going to Australia as well, isn't it?
Yeah, we've got one of the new ones going over to the boys in Australia.
Assembled?
It will be one of the ones that I've assembled, so no pressure.
Yeah,
no pressure.
Yeah, exactly. So you get someone calling you up at midnight, 9 a.m. for them, going, Paul, what's happening, mate? Paul, what's happening with this laser engraver, mate? So that's brilliant. What I find really interesting is so let's back up a little bit. How did you actually design and develop this laser machine? I mean, I know it's not a laser machine is not as a laser engraving machine is not as complicated as a CNC machine, for example.
No.
You need to either hand scrape or set linear guideways up. There's a lot more going into the manufacture of a CNC machine, but it's not an easy thing to do, to design a laser engraver from scratch.
No, it's I think for us, we've been involved with lasers in one form or another for a number of years. Never been entirely comfortable with what we've been using, and we've sort of listened to our customers, and they've given us a lot of feedback about what they want. And so what we decided to do was to try and build something that would suit a customer needs. And one of the things that came to the fore was that they would like something that was built in the UK rather than something that came from outside, and something that offered a UK base with UK support, telephone support, obviously engineering support. And that was sort of the starting point for us deciding to build our own machine.
Yeah, and what gave you the confidence to think here at Colchester to actually say, you know what, this has been an idea we've had, let's actually put pen to paper, let's start designing, let's start investing money. It takes a lot of time and energy and capital to start designing a project like this. And I mean, you must have a lot of engineering, not only expertise in the office, but also resource, workshop space. We can hear machine tools running in the background.
Yeah.
We can hear people working with power drills. There's obviously, this isn't just a showroom, is it?
No, absolutely not. No, the other side of the wall there, we've got a fantastic resource. We've got a machine shop. We've got design engineers. We've got electrical engineers. We've got all the resources that we need to be able to tackle any project. Quite frankly,
not just a laser engraving.
Not just laser engravers. Now we can pretty much do anything.
Yeah, so a huge amount of engineering expertise that's applicable to a lot of different problems
Yeah,
customers might
absolutely,
have. So
yeah.
turnkey solutions as well.
Yeah, absolutely. Turnkey solutions. I mean, just with the laser, for example, we manufacture jigs for different applications. We manufacture a lot of different components that people use within the marking and traceability field. So, yeah, we've got everything we need, really.
Brilliant. So we set the stage with everything you need to build a laser engraving machine and design one as well. And I'd like to know a little bit more about the experience you've had with what customers are using these laser engraving machines for, and how that has informed the design you've come up with.
Yeah, I mean, basically the laser is it's a 1064 nanometer fibre laser. And it's designed for marking metals. There are other lasers out there that all equally mark metals, but what we wanted to do is we wanted to build a small desktop laser, but something that was very high spec, so something that offered a lot of control in the marking fields, the ability to put a decent part size in there. A lot of the applications that lasers get used for, it might not just be a single part, it might be a whole tray of smaller parts, and obviously the bigger marking field you can put in there, and the jigs and trays or whatever you need to put in there. If it's only once in, once out, rather than 50 times in, 50 times out.
Yeah, you want to do it in batches, I guess, if you can.
So batch marking, that was one of the things that we wanted to address.
Yeah.
A lot of places will not just use one material; they'll use a variety of different materials for the products that they're manufacturing. So again, we wanted a laser that was flexible enough to be able to mark all the materials that they were using in there. We wanted, a decent marking bed so that people could put decent part sizes in there. If they wanted, they could also have an interchangeable lens to change the field size. We designed it with the ability to put different laser sources in there, so if people wanted more power for deeper engraving, for example, it's a very simple fix for us, the way that it's designed. It doesn't matter whether it's a 20 watt laser or whether it's a 100 watt laser. We can just literally use the same cabinet, the same build, and just put into it effectively what we want or what that customer requires for their application.
It sounds good, and that's for me. That's the difference between a good design and a great design. Is you can design something that's good, that is fixed with the specs you've chosen. Maybe it's not so well maintainable, but it works. But a great design is something you can maintain, you can upgrade, you can change, and is flexible to what you actually need, because you've got no idea what customers might be using it for in a year from now.
Absolutely, and things change. I mean, you very often find that when somebody buys a laser, they'll buy it for a specific application, and then once their other customers discover that they've got a laser in there, they then want to look for things like their own branding, so they might want their own logo put in on there, and a lot of our customers manufacture for other people with other brands and other logos. So we just wanted to get as much flexibility into there as we possibly could, and build something at an affordable price as well.
Yeah, absolutely. Because you've got it in-house, I guess you can control costs a lot easier.
We can control costs a lot better, yeah, absolutely.
Yeah, which is brilliant. Especially when there's supply chain disruptions happening quite a lot. I mean, when it comes to in the machine tool world, there's Heidenhain, Siemens, Fanuc controls that we all know and we all rely on. There can be vastly different shipping times, lead times for these controls, and also prices change quite a lot.
Yeah.
So when you control everything on your machine tool, you can swap out products and components to save time, save money, and at the end of the day, get a better product to a consumer at a better price. Yeah,
that was the whole essence of this. We just wanted control of our own product.
Yeah, brilliant. And so you talked a little bit about the applications of a laser engraver. We talked about kind of serial numbers on metallic components, and that's so that that each metallic component has something unique. Because if you've got 50 of a round part, they're all interchangeable. As soon as you serial mark them, they're all identifiable. And once one is taken out, you know what batch it's come from, what material has gone in, and how it's gone around the shop floor. And that's really useful. Traceability, you've built a career on, but you've also talked about logos now, and that kind of we're peaking on something slightly different to traceability. It's called there's applications in kind of more cosmetics. Cosmetic designs.
The branding is, as you know, is so important nowadays. And
let me check the branding. These MTD muffs. Yep, microphones
there
are good.
You go. So. The branding is very important. You want people to know what you're supplying. So if that's your product, it's a popular product. You want people to know that that's your product, and it sort of translates through from just branding right through to personalisation. Personalisation is a big thing nowadays. Everybody wants personalisation. You look at everything that's out there and people want something that's unique to them. They want some form of personalisation. And again, with this particular laser, we wanted to look outside the machine tool market. So it's been designed and it's been spec'd with the ability to mark jewellery and to mark, again, personalisation, gifts. You see it on the water bottles now, and there are just so many applications out there for giftware that we really wanted to look at that market as well.
Absolutely.
So it's not just designed for a machine shop.
Yeah.
And the way that it's been designed, you could quite happily stick it next to your microwave in your kitchen. It wouldn't look out of place, and it would be as safe as your microwave. So that's sort of where we were aiming for with it.
Yeah, it's fascinating that you started in products that are solely for machine shops. And this is more of it's not a consumer item, it's an industrial ready product.
Yeah.
But you could still find it, like you say, in someone's home if they've got a little side business doing customized jewellery. And you've got a little rotary table in there, it's a little option.
That's right,
and that's what you could put a wedding ring on or something,
wedding rings,
something circular.
Any sort of jewellery really.
Yeah.
Again, the personal touch. You see all the stuff that's out there with the charm bracelets with information on weddings, anniversary dates. Something that's an important date or an important person to somebody. You can capture it forever with a laser mark, because the whole thing is the laser mark's a permanent thing. Yeah. It's not going to disappear.
Absolutely, and it might be actually a good opportunity for machine shops that are trying to diversify themselves. So machine shops that are looking to move away from just doing subcontract components. Quite a lot of them are looking to sell their own products, and if they can come up with some product that includes personalization using laser marker, they can make the components on the machine tools, they can personalize it on the laser engraver, ship it out. You could even automate some of that process as well. Yeah,
absolutely. I mean, again, the laser's been built with automation in mind. So we have an I/O socket on the side which we can use for signalling. So again, looking to the future. If people want to use, say, a robot for loading and unloading, which is a great use of a resource, and it removes one of business's most costly elements.
It's a human being.
Yeah, away from a mundane job,
and
puts them into an environment where they can be far more profitable and far more useful. So we've designed it with the future in mind as well.
Yeah, perfect. So that's the Lightning, is that right?
That's the Lightning, yeah.
The Lightning laser engraving machine from Colchester Machine Tools, designed here, assembled here. Made in the UK, and I'm not seeing a big Union Jack. Normally, if people make stuff in the UK, they put a big Union Jack on it.
No, we're very discreet.
Oh, yeah, okay, brilliant, yeah. Lot to shout about, but you whisper it.
We whisper.
It's beautiful. Hopefully, MTD can help you get that word out a little bit better as well. And there's a couple of Easter eggs in this podcast. If you're watching, then you'll see exactly what I mean, because we are recording just before the Easter weekend, and obviously this will go out a little bit later than that, but. For those, a belated happy Easter to everybody who's going to be enjoying the Easter weekend, probably, and they'll be listening to this once they get back to work, unfortunately, but we're all looking forward to that 4-day weekend. Another thing we're looking forward to is MAC is coming up.
Yes.
Yeah, so that's the 15th to the 18th of April, I'm pretty sure it's 5 days, at the NEC in Birmingham, so MTDCNC are going to be there. We also have a machine the lightning laser engraver is going to be there. So
yes, it will. Yeah.
And that's the premiere.
Yeah.
So we've had thank you very much, a sneak peek.
Yeah.
We've been able to see it physically, but first time the general public will be able to see the lightning laser engraving machine made, designed, assembled here at Colchester in Elland. It's going to be at Mac. What's your stand number?
We are in Hall 6 and it's stand 240.
Perfect. Very well remembered. We had to read that up about 2 hours ago. So yeah, Hall 6, stand 40 for the Colchester Machine Tools stand. You'll be able to see that laser engraving machine there, and I guess you'll be doing some kind of demos.
Yeah, we will. We'll be doing all sorts of different things with it.
Yeah, exactly. And another sneak peek. I guess the demo might be something similar to what we did today.
Possibly.
Yeah. So Paul took a photo of me pulling a very silly face. And then they engraved it on a white, kind of almost a business card style thing, and it's really cool. Amazing how quick you can take a photo, turn it into something physical, not printing, turn it into something laser engraved on a piece of plastic or a piece of metal. And the cycle time was pretty quick, wasn't it? What was it?
About 37 seconds, I believe.
Yeah, to do a human's head and shoulders on a piece of plastic, absolutely fantastic. Really great piece of tech, and I think that's pretty much it. I'll be looking forward to seeing you guys again at Mac, hopefully.
Yes, sorry.
Yes, all right. We look forward to seeing you guys at Mac, and that's the MTDCNC podcast here at Colchester Machine Tool Solutions. And once again, thank you very much, Langley Alloys, for sponsoring the podcast. Check out Langley Alloys. They've got a facility in the UK and in the US. They can supply lots of special materials for your needs in Inconel, super duplex, really corrosive resistant, high performance material applications. So that's it. Thank you so much for listening to the MTDCNC podcast. We'll see you next week.
Thank you for listening to this episode of the MTDCNC podcast, sponsored by Langley Alloys, specialists in a wide range of exotic materials for any application for all your engineering needs.